So let's try this example of the fast exponentiation. So we are trying to compute 2 to the power 77 mod 11 using the square and multiply again. Again, for our illustration, we are using the two variables c and d. It's again only optional. It's used to see that you are computing correctly and using correctly the exponent, arriving at the right value. But in production environment, you only work with the d value. And we are going to start with the exponent. We start with a 0. That's just academically. You can start with a value 1 and then you start actually from the next step on. But if you start with a 0, the original exponent, so far it's 0. And 2 to the power 0, it's 1. Power 0 is 1. Then we are going to expand the exponent with one value, and we are getting 0, 1. 2 to the power 0, 1 is 2 to the power 0 shifted to the left with one position to which we add a 1. Shifting to the left with one position corresponds to multiplying the previous value with 2. And then we add a 1 to it. This is because the current bit is a 1. Multiplying with 2 corresponds to squaring, so we have 1 square, which is equal to 1. And multiplying and adding a 1, so 2 times 0 was 0. When we add a 1, the current exponent becomes 1. And adding the 1 corresponded to multiplying the value with the base, because this corresponds to 2 to the power 0 plus 1, which is 2 to the 0 times 2 to the 1. So we multiply the with the base the current value. So it's 1 times 2, which is 2. Next, we again extend the exponent to the right with the position. The current bit is 0. It corresponds to multiplying the exponent with a 2, so it's 2 times 1, and the current bit is a 0. 2 times 1 is 2. Adding 0 does nothing. Multiplying the exponent with 2 corresponds to squaring the base, which becomes 4. Again, we expand the exponent to the right, which corresponds to multiplying the current exponent with 2 and the current bit of 0. It's added. Multiplying the exponent with 2 corresponds to squaring the base, which becomes 16. But 16 mod 11 is 5. So actually you are going to write here directly 5. Adding a 0 does nothing. We expand again the exponent with one position. We get the bit 1. Expanding it corresponds to multiplying the exponent with 2, so it's 4 times 2 plus, I've always written it in the other way around, so it's multiplying the 4 with 2 plus a 1, which makes 2 times 4 is 8, plus 1 makes 9. Multiplying the exponent with 2 corresponds to squaring 5, which will be 25. 25 mod 11, it's 3. Again, remember we are working mod 11. Adding a 1, which leads to 9, corresponds to multiplying the 3 with the base, which was 2. So it becomes 3 times 2 is 6. We again extend the exponent with one position, which corresponds to multiplying the previous exponent with 9 with 2, with adding the current bit. Exponent becomes 18, and plus 1 is 19. Multiplying these two corresponding to squaring. 6 squared is 36, 33 plus 3. So that's 6 squared, which is 36. Mod 11.
The 6 right there, shouldn't that be 5?
This one?
It's 4 squared.
This one here?
Yeah.
We obtained it by multiplying 3 with a base which is 2. Yeah, 3 times 2 is 6. Mod 11 remains 6. So this one over here corresponds to multiplying this 3 times 2 again, which again is 6. We expand again the exponent with one position. It's a bit of 0 that's currently obtained. 2 times 19 plus 0. 2 times 19 makes 38. Plus 0 remains 38. Doubling the exponent corresponds to squaring 6, which again it's 36 and 3 as before. And the last extension of the exponent leads to 2 times 38 plus 1. 2 times 38 is 76, plus a 1 makes 77, because the current bit is 1. So doubling of the exponent, it's again a squaring of the current value, so it's 3 squared, which is 9. And the plus 1 corresponds to multiplying 9 times 2, which is 18, which mod 11 makes 7. And we arrive at the end. Therefore, 2 to the power 77 is equal with 7 mod 11. Again, as before, the row we see was just for checking that we arrive at the right exponent, that we don't lose any bit anywhere on the way. And in a production environment, you just wouldn't use it.